Hello guys, my name is Darren from section 2. So today I'll be discussing about the association rule. So what exactly is association rules? Association rules are actually an if-then statements that help to show the probability of relationships between data items within large data sets in various type of databases. So in this context, we can know that um, it is from the word association, we can actually know that it is connected with the meaning of relation. So association rule actually it is showing the probabilities of relationship. How likely will two different data items in a large data sets occur on the same time? So I'll give an example. For example, for people who buy a phone, they will most likely to buy a phone case or tempered glass, right? So we can use association rule here to find out the relationship between the probability of people who are buying phone and also how likely will they buy phone case and also tempered glass or other some sorts of phone accessories. So this is actually what association rules means. So I will conclude again, association rule is like showing how frequent people who get item A will also get item B. This is an rough examples. Yeah. And also how likely for item A to occur with the occurrence of item B. Yeah. So this is association rules. So what are the applications for association rules? So usually association rules is widely used to help discover in sales correlations, especially in transactional data and also in medical data set. An important rule to apply association rule is that the data size must be big. So usually in sales or also medical sets, they have a large data size. So it is extremely useful for analyzing and predicting customer behaviors in sales industry. So this is because like I'm the example I mentioned before, we can know the demand of the market by knowing the relationship between those items. For example, I'll give another example like people who buy rice, how likely will they try to buy oil, sugar, and salt, something like that. So we can use association rules to know the relationship between rice and also sugar, rice and salt, rice and oil. We can know whether if there is any association between these two items, any relationship between these two items. And it is extremely useful for us to analyze the market and also the demand for in the market for the customers. So it is extremely popular to be used in market basket analysis and also product clustering and so on. So one of the examples for when association rule is applied is in medical diagnosis. So usually in medical field, they need to compare a lot of medicines and also sickness and also the contents of the medicine. So in when we try to, we it is widely used in medical diagnosis. So association rule can actually helps to determine the relationship between maybe we can go for the like um, medicine A and also sickness A. We can find a relationship whether if medicine A is actually cure can medicine A is how effective is medicine A against sickness A. So not only that, it is actually used in the medical sales, people who sell medicine. For example, like in pharmacies, if we try to know which type of medicine is has the highest demand in the market, and also we need want to find the relationship between the highest demand medicine and also its relation in relative to another type of medicine. So for example, like people who customer who bought paracetamol, um, beside buying paracetamol, most likely when they bought paracetamol, what kind of medicine would they try will they buy also? So maybe it can be like antibiotics and so on. So usually, a rough example is that people who usually buy paracetamol, we can apply association rule to find out that how frequent people who buy paracetamol medicine will like most likely to buy the antibiotics medicine. So it is actually a relation. So in conclusion, this whole association rule is actually finding the relationship between data set. Like I bought item A, how likely, how frequent will I also get for item B? If event A occur, or how likely will for event B to occur? It's like a relation. That's what association rule is all about actually. Yep. So I'll move to the next part, which is the frequent pattern mining. So frequent pattern mining is also known as the association rule mining. As you can see, it is actually connected with what I have mentioned before, which is the association rule. So the difference is that frequent pattern mining is actually an analytical process. It is a process to find the frequent patterns and also associations from data sets. So actually, this frequent pattern mining process, aims to help us to find the rules and also help us to predict the occurrence of a specific item based on the occurrence of other items in the transaction. It is actually roughly the same with the association rule just now. So same as it goes, I will still use the same old example, which is the phone and phone case. People who buy phone, how frequent will they also will buy the phone accessories like tempered glass, phone case, keychain, and so on. So it is actually the same thing as what I have mentioned before, but and then it is actually used in a large data set and also usually in a transaction. So this is because transaction there is a lot, they have a large sample size, and also it is frequent pattern mining is actually almost similar to association rule mining, but it is actually a process of analytical process of how frequent item A and item B occur at the same time. Yeah, it is the same, almost the same with association rule. So how do we implement frequent pattern mining? And also what are the rules of frequent pattern mining? So the rules for frequent pattern mining is association rules. So frequent pattern mining can be implemented in many ways. Mostly they implement it in business industry and also for market survey, market analysis. So the the rules they use is association rules. So here we go again. Association rules is what I have mentioned before, is the relationship between two data items within large sample size. So um, as you can see from the formula here, this formula actually is actually the formula for calculating frequent pattern mining. It is actually the formula for us to calculate how frequent item A and item B uh, occur, how close is their relationship. It is actually the probability. It is actually the probability calculation. So frequent pattern mining, yeah, it is the same with association rules, and it is, but the difference is that frequent pattern mining is the process where association is rules itself. So yeah. So in conclusion, frequent pattern mining, we can understand that it uses the rules of association, and the and it actually helps us to find a specific items within a large sample size and also find out that the and also find out that the specific item, how closely or how relatedly or how frequent it is connected to the item, the other item set. So this is actually frequent pattern mining. We try to see how most likely, how what is the trend, what is the product trend, and also um, how high is the probability for getting product A, and getting product B at the same time. So it is like association rule. It is still basically roughly the same thing. Okay, now we'll go to a priori algorithm. What is a priori algorithm? It is actually an algorithm for frequent item set mining and association rule leaning over relational database. It proceeds by identifying frequent individual items in the database and extending them to larger and larger item set as long as that item sets appear sufficiently often in the database. So a priori algorithm is actually like it is actually a bit similar to association rules. It actually uses association rules. So a priori algorithm actually it helps to um, I'll give a rough example lah. For example, if I want in a large data size, in a large data sets, if I want to know um, how many people buy phone among all the electronic gadgets, if I'll give an electronic gadgets as examples like among all the data sets of electronic gadgets, how likely people will try to buy phone? Yeah, I'm going to use back the previous example. How likely will people going to buy phone? So by using a priori algorithm, it actually search filter the customer who bought phone. It will try to always extend the data sets until sufficient sample size is reached, sufficient amount of people buying phone, and then it will try to compare those people who buy phone to people who buy um, other product. How likely will people who buy phone buy other product? Maybe like phone accessory, like I mentioned before, like the tempered glass, the phone case, and so on. So the difference is that the a priori algorithm it always extends. It always extends the data sets until it reaches sufficient occurrence. So and also it applied back the association rules to find the relationship between people who buy phone and people who buy the phone accessories. So we'll go for how is a priori algorithm different from other algorithm. So a priori algorithm are actually purposely designed for databases that contain transactions. For examples like collection of items bought by customers and also detail webs of a website frequentation or IP address. Well, whereas the other algorithms are designed for finding association rules in data having no transaction. So the main difference is a priori algorithm is widely used in the business industry which involve business transaction, because a priori algorithm is very effective in determining the market relationship and also the market supply, the market demand, and also the uh, market needs. Whereas the other type of algorithm, they actually not really focus on business side. They actually focus on maybe like the DNA sequencing medical side, which does not involve any transaction. They just the other algorithm just like merely implement the association rule, whereas a priori algorithm try to extend the data sets until it gets sufficient amount of data size, and it try to apply back the association rules, and it actually filter and find out the relationship between item A and item B, which is extremely good and important in business industry. So this is how a priori algorithm different from other algorithm. Uh, okay, so we'll go for the disadvantages and disadvantages of a priori algorithm. So the advantages for a priori algorithm is that it is actually easy to implement and it uses large item set property. So one good thing is that a priori algorithm is effective, especially when dealing with large data set. But um, it is also easy to use because we can like search for compare a specific items with another items and find out the probability and so the relation between them, and also the frequent, how likely will those two occur at the same time. So this is the a priori algorithm, and also it uses large item set property, which actually increases the accuracy of our results. Because since we have a larger data size, we can have a more accurate result, accurate prediction, accurate like trend. Yep. So the disadvantages of the a priori algorithm is that it is very costly and wasting of time. This is because it uses the large item set property. Even though the result may be more accurate, but due to it keep on extend the data, the item sets until it reaches sufficient amount of occurrence, it is very time costing. Even though it is the result can be more accurate, but it actually wastes a lot of time, especially when people who do business they need to have the urgency of time. So it actually, yeah, the large item set property actually causes it to be time consuming, and also they have a low minimum support for the large item sets, which is a bad thing for them. This is because not all the computers and also can handle the large item sets. So yep, so this is the disadvantages of a priori algorithm. So in a nutshell, a priority algorithm is an algorithm used widely in business industry. So people who do business can use this algorithm to find out the demand of the market and also the relationship between um, between specific items. So it is extremely good, and even though it may be time consuming, but I believe that the output is worth it because it uses large data size, which actually increase the accuracy of the result uh, we get. So I think that's all from me. Thank you.